Okay, we are going to move on in chapter 3 today. We're in lesson 3.3, and we're going to talk about rate of change and slope. Hopefully, pretty much everything we do today is going to seem familiar based on things that we did last year in pre-algebra. Last year, rate of change, we spent some time on rate of change, and then later on, we spend time on slope, and we kind of differentiate between those two things a little bit. But in algebra, we're just going to cover these in one lesson, and really, they're pretty similar. They're pretty much the same thing. You need to remember how we talk about rate of change, and this is the same thing for slope. What's the letter that we use for slope, by the way? M. So we could also say M equals rate of change, or M equals change in y over change in x. And the way that we do change in y over change in x is we subtract between two y coordinates and subtract between two x coordinates. So that formula y2 minus y1 over x2 minus x1. You should remember that, hopefully, or at least it sounds familiar. So that's what we'll be using a lot today. We'll just jump straight into some examples here. All linear functions have a constant rate of change. If it makes a straight line, then it's a constant rate of change. So you only have to check 2 points on the line to find the rate of change, and then all the rest of the line is going to have that same slope or that same rate of change. Harley.
Why is y on top of the fraction and minus y1?
That is a great question. And it goes with one of the other things that we used to talk about was slope, and I don't have it on here, but slope, another thing that we talk about it being is it's rise over what? Run, okay. And so rise is the up and down of the graph, which is the y value, and run is the left and right of the graph, which is the x value. Rate of change, it's a rate, it's a ratio. And ratios always have to be set up the same way. If you change the parts of the ratio, then it changes what the ratio says. And so whoever, back whenever this was invented or discovered or whatever you want to say, decided that the way we describe slope is it's going to be that ratio of rise to run, not run over rise. So, well, you know, when we always teach you when you're graphing to count the x, you go left or right first and then up or down, because that's the way the ordered pair is with the x and then the y. So yeah, it's, you know, some differences there, but it all works. You just have to keep it straight in your head. All right, so here's where we're at. All linear functions have that constant rate of change. In these next two slides, we're going to have linear functions that do have a constant rate of change. So we just need to pick 2 points and use our formula. What was that rate of change formula, by the way? y2 minus y1 over x2 minus x1. So we need to plug in some numbers for those variables. Give me a y2 number. 156 can be our y2. What would be our y1? 78. And then our x2. x2 has to be, why does x2 have to be 4? Yeah, you have to use the ordered pairs, right? If I use 156 as the y2, then 4 has to be the x2, so it's got to be in the same place. So then what has to be x1? 2 has to be. All right, so 156 minus 78 is 78 over 2. And it simplifies to 39 over 1. Now, then explain its meaning, and you're going to have to do this today with your assignment. I'm not content with just knowing a number. I want to know what this number means. Joaquin.
One computer game is $39.
That's right. We're just talking about the cost of computer games. If you get 2 for $78, that means you got one of them for $39. So $39. And if you're going to write out its meaning, you just say each computer game costs $39. You don't have to write a paragraph, but it would be nice if you wrote a sentence that describes what it says, right? Okay. So the next example, the table shows how the tiled surface area changes with the number of floor tiles. So as you're laying tiles down in the kitchen or the bathroom or whatever, and the amount of space that is tiled changes the more tiles you lay down, right? Okay, so what was that formula again?
y2 minus y1 over x2 minus x1.
Okay, x2 minus x1. So we need to fill in those variables. What's my y2 number?
48 or 96.
Okay, 96 minus 48 over 6 minus 3. Okay, so 96 minus 48 is 48 over 3, and then simplify 16 over 1. Now, what does it mean, Harley?
That every tile, covers 16 inches square.
That's right. That's exactly it. Each tile is 16 square inches. Okay, Harley?
I have a question. So if you just have, if you know it's a linear function,
Uh-huh.
couldn't you just divide 48 by 3 to get 16 over 1?
That works on this one, but it's not always going to work because not all linear functions go through the origin. And we're going to in our next lesson, we're going to talk about this special types of functions that always go through the origin. They have a special name. We work with them in a special way. And it happens that this one did. I mean, obviously, if you have 0 tiles laid down, you have 0 surface area covered by tiles, right? With the last one, if you buy 0 computer games, you pay $0. So those are both, they're called direct variation functions. So they're both direct variations. They go through the origin, but not all linear functions go through the origin. So we'll talk about that more with our next lesson. Okay? Good observation, though. I like where you're thinking. On the next page, we've got it again. Rate of change and slope are the same thing. Slope is really where we talk about rise over run, but we use the same formula for rate of change and for slope. And so, if you don't have a picture, if you don't have the graph so that you can count the slope, counting the rise and run, then you need to use ordered pairs in order to find the slope. And so we'll do that with these examples here real quick. So slope is, set it up. So y2 minus y1 over x2 minus x1, right? Oops, x1, not xy. So the x values come first, x, and then y and y. So what do I want on top? I want 0 minus 5. Negative 2 minus 1. So that's going to be negative 5 over negative 3. That doesn't simplify. Well, it kind of does. What's a negative over negative? Positive. So it's really a positive slope, right? And you can you picture that in your mind, what a positive slope looks like? What does it do? Goes up from left to right. So it's going to be going that direction, right? Up 5 and then over 3. All right? Let's do this next one, number 2 here. Slope is, set it up, negative 3 minus 4 over 2 minus negative 3. So what's minus a negative? It's really plus 3, right? Okay. So negative 3 minus 4 is negative 7 over 5. So that's a negative over positive. We'll leave it just like it is. What's that slope look like?
It's going down.
Yeah, that slope is going to be going this direction, right? Down from left to right. All right, number 3. Slope is minus a negative is plus 1. Plus 1. Excuse me. Over 2 minus negative or plus 3. Okay, so that is 0 over 5.
So wouldn't that mean this goes over the x-axis and just goes straight across the x-axis?
It is no slope. If you have a 0 on top of your fraction, what's 0 divided by 5? It's 0, so it's a 0 slope. And a 0 slope is, whoops, that's not very horizontal. I'll do better with my straight line tool here. A horizontal slope, or a horizontal line rather, has a slope of 0. And so if you come up with 0, it's going to parallel the x-axis. It might be right on the x-axis, although this one would not be. This one would be where y is -1, right? So it's going to be 1 unit below the x-axis. And it's going to be parallel to the x-axis. Harley?
So for the next question, number 4, would it be no slope?
Nope, let's do that one here. So let's set that up. Change in y is
Isn't that all numbers or something?
-4 minus 3 over 4 minus 4. And so that is, well, -4 minus 3 would be -7 over 0. But this is the part we want to talk about, having 0 on the bottom of a fraction. What does that mean?
It's just negative 7.
It's not -7. What happens if you can't, what happens if you put,
It's not divisible.
sorry, I'm not speaking English.
It's not a number.
If you put -7 divided by 0 in your calculator, what do you get?
Error.
Error, because you can't divide by 0. Okay? Because it doesn't work. It's not mathematically possible to divide something by nothing. Okay, you can't do that. So it's 0. It's not 0.
It's not a number.
It is. There's a special word for it. It's called. Starts with U, ends with
Undefined.
undefined. There you go. It's undefined, and it is a line on the graph. A line on the graph will represent this.
Right up the line.
It is a vertical line. It parallels the y-axis. Oops. It
Could be,
parallels the y-axis, so
could be over 7.
yeah, it's where x is 4 actually. So if you think about what the graph would look like, if you have if you have your graph, you'd count over 1, 2, 3, 4, and you'd have that vertical line right there where x is 4. Parallels the y-axis. Okay. And so you need to recognize that. It's okay to have a vertical line on a graph, isn't it? Yeah, but you just need to recognize that it's a special type of slope. It's an undefined slope. Okay, that's the word it needs to be, undefined. This one is no slope or 0 slope. This one is undefined slope. You with me? All right, last slide here. Not all functions have a constant rate of change. Okay, first of all, does this graph represent a function? How do you know?
It increases and decreases.
It passes the
Line
vertical line test, right? If we pass a vertical line over the top of the graph, oops, can't grab a hold of that. If we pass the vertical line over the top of the graph, it never touches more than 1 point at a time. So it passes the vertical line test, so it is a function. But it does not have a constant rate of change. We can see that on the graph. It goes up kind of quick here. It doesn't go up very quick at all here, and then here it goes up really quick, right?
It's not a multiple slopes.
It just has, yeah, it just doesn't have a constant rate of change. It has a variable rate of change. And so what we have to do then is we can't just choose any 2 points. We have to look at the specific points that the question asks about. So find the rate of change for 2000 to 2002. That'd be from this point to this point. So I need the y values for those 2 points. And they're kind of listed. Those are the numbers there that they give you so that you can read it better.
Would that be 315?
Well, it's labeled. Just look at the numbers that they give you.
Y increases by
Right here,
7.
right here. So we're gonna solve it. 324 minus what? 317. There we go. Over 2002 minus 2000. Okay. So 324 minus 317 is 7 over 2. So it has a rate of change of 7 over 2. What does that mean?
It increases by
Okay. And really, on this type of graph, we really, even though it's going to give us a decimal, we want to go ahead and divide that. What's 7 divided by 2?
3.5.
3.5. What does that mean? 3.5 what?
Billion people.
Every year, 3.5 more people come to the park.
3.5 million more people attend the park each year compared to the previous year. Okay.
Yeah.
So there you go. So you can interpret that. Now let's look at 2002 to 2004. That's from here to here.
it goes up by 1 person or half a person.
Okay. Well, let's do the math. It's 325 minus
324,
324 over
2004,
2004 minus 2002. So that's 1 over 2, which is just 0.5. So that's
by half a million people.
500,000 people per year increase in park attendance. Okay. So that's what we're going to be doing today. You're going to be finding rates of change. You're going to be interpreting what those rates of change mean, describing the rate of change, the slope, and telling me what those numbers are for, okay? Here's your assignment.